Hello and welcome to our analysis of iCAT24, part of our full-length mock test series for CAT. In the first two parts of this analysis, we saw the verbal and DILR sections and saw which questions to attempt, how to go about attempting and selecting them, and which questions to leave out. In this particular part, we will look at the last and easiest section of CAT, that is quantitative aptitude or maths. Now typically people, especially non-engineers, tend to be afraid of maths because they think they've not done it after 10th. But as we keep telling students all the time, the quant that you will see in CAT or other exams is typically based on what you've learned in school, not more than that. Now, over the last 3 years, quant has become the easiest section as far as CAT is concerned. Before I move to quant, let me first point out that in this particular mock, the overall difficulty was easy to moderate. For people accessing our video for the first time, this 1.77 essentially implies that each question was slightly easier compared to moderate. What we do is there is an LOD or a level of difficulty ranging from 1 to 3 assigned to each question, where 1 is the simplest. So here it means that each question roughly had an LOD of 1.8. So let's move to quant. As always, 34 questions. The average difficulty here was just above 1.5. So it can be said that the section was really easy. In CAT, you can potentially expect it to be somewhere between 1.6 to 1.65. So here, going by the trend of the entire mock, you would see that each of the sections was marginally easier compared to the actual CAT exam. I will come to the number of good attempts later when we have a look at the entire section. So the first part that we see here is, as I said, we divide each question into 3 parts or 3 LODs. LOD 2 is moderate, 3 is tough. Now in 1, we further divided it into 2 parts for CAT. So here let me start with the toughest part. This entire section was easy mainly because there were only 3 tough questions spread over the entire section, so that's less than 10%. 13 questions were moderate, which is the typical breakup that you will see in CAT. If you observe CAT, you will see that there are anywhere between 14 to 15 easy questions. Now when I talk about CAT easy question, they include the sitters as well. So here we have 18. You have somewhere around 12 to 13 moderate questions, which more or less is matching here. And the remaining 6 to 7 questions are tough, which is slightly less here with 3 questions. So this drop and this increase makes my section slightly easier compared to CAT. What we've done here is divided the easy questions into 2 parts. So the 18 that I have are further divided into 10 easy questions, which means that's a slight level of application, and 8 sitters, which means that they are so simple that you just need to know a formula or just need to know how to solve it, and that can be done. So that's the basic analysis in terms of what was the breakup by difficulty level. Let us now move on and see which questions were actually the sitters. So as you can see, these are the question numbers that we have classified as sitters. Please remember that it is not necessary that what we call a sitter is always a sitter for you. Somebody might not be comfortable with, say, coordinate geometry and hence may find it easy or even moderate. What I have called a tough question here might be easy for somebody because he is comfortable with interest and growth rates. So we would recommend that you go through these tables once after taking the test and after seeing the solutions or solving the questions, and then try to judge why we have called it a sitter or why it is a tough question. If we've called it a trick question, why is it a trick question? You can always come back and ask us doubts and we'll be glad to help you. Now having seen the number of sitters etc., we now also need to see how the questions were distributed in terms of by chapter. If we look at this, and this gives us a much clearer picture in terms of how the paper was split. As we said, the average difficulty of the test was around 1.5. Obviously, when we talk of average, some values will be above it and some will be below it. So modern math was more or less at the same level, whereas geometry and arithmetic were slightly tougher. On the other hand, the area that a lot of people are scared of, algebra, was the easiest in this exam. So when we consider this aspect, what I would like to tell people is that people very often think that only arithmetic will be easy. However, that is not the case. Here, arithmetic was on the tougher side and geometry was on the easiest, or algebra was on the easiest side. So people who would have attempted these 9 questions of algebra are much likelier to clear the cutoffs compared to somebody trying to solve the 9 questions of geometry. Whatever was the difficulty in this paper was a combination of these two factors. 9 questions in geometry with a high difficulty level. This would have been a disappointing part for some people because a lot of people bank on arithmetic in the exam. Arithmetic typically would be slightly easier than this, so here you would have seen a lot of moderate questions instead of easy. What I would have attempted in the exam is these 9, potentially the easy questions here, and then maybe moved on to some part of this. But this 9 plus 9 plus 7, that's 25, would possibly give me somewhere around 21-22 attempts itself. Having looked at this, there is one more way in which you can look at the entire test to get 2 important learnings. Try and understand this graph. What we've done here is we've plotted the difficulty level of each question from question number 67, that's the first question of this mock in quant, to question number 100, that's the end of the test. The blue lines indicate MCQs, the orange lines indicate theta or numerical entry questions. Now when we look at how the difficulty was spread, and you should look at this after each exam, so it tells you how your attempts were spread compared to, let's say, the difficulty. For example, if your score was low and you observe that a lot of your attempts were in this range, then it is very likely that you attempted the tougher questions and missed out the easier ones. Observe that there is a huge chunk of easy questions from question number 90 to question number 96 with 2 theta or numerical entry questions. So this is something that should definitely have been attempted. At the same time, if you observe this particular lot from question 71 to question 79 is where we have the moderate questions followed by a tough question, again followed by a bunch of moderate questions. So here the key is question selection. Just because this chunk is tough, I should not be missing out this question. Sorry. Just because again this chunk is tough, there's an easy question here, these two, this. So you need to hunt for these questions. There'll be a patch or a phase in the paper where you will find 5-6 such questions in a group. But otherwise they will be scattered. If you see, you have 2 here, 1, 1, 1, 2, 1, 1, 2. So out of the 18 easy that we identified, just about 10 or 11 are separated. The rest are in a group. So the key is to find them. That becomes one of the important learnings from the analysis. So what are the things that we need to note? And I'll come to 2 other points later when we look at a few questions, but broadly from these graphs, 2 things. 1, please do not go in sequential order. Here as we can see, the middle part of the paper has a lot of tough questions, while the end has a huge part which is easy. So have a look at the entire section first. 2, look out for the easy questions. Anywhere around 13 to 15 questions out of 34 will be on the easy side. So look out for these questions. Identify the moderate ones, try and avoid the tough ones. That is one aspect. Second, you have 4 broad areas: arithmetic, algebra, geometry and modern math. Please do not bank only on one of these or 2 of these to do well. Ideally, I would say you should look at any 3 out of 4 to be reasonably good. You can get away with one of them being slightly weaker, but you cannot have all, one of them being terrible. You need to be reasonably good at all 4. Having said this, let's now have a look at a few questions and see how they could have been done faster, either using shortcuts or through the knowledge of special concepts. Now, for instance, let's look at question 69. Consider the set of numbers from 2 to whatever, where n is a positive integer larger than this. If O is the average of odd integers, E is the average of even integers, what's the value of O minus E? Now, firstly, note that my set is 2, 3, 4, so on, up to 2n and 2n plus 1, because 2n plus 1 is the odd integer. So, if I observe, my set is actually of the form, my even set is of the form 2, 4, 6, so on up to 2n, and my odd set is actually of the form 2 plus 1, 3 plus 1, 6 plus 1. Sorry, here I made a mistake. It should be 2 plus 1, 4 plus 1, 6 plus 1, so on up to 2n plus 1. So each set has the same number of terms. When two sets have the same number of terms, the difference between their average is nothing but the difference between their totals. So we don't really need to find the average. We can just take the difference between the totals and then divide by n. This is nothing but n terms. This is again n terms. So the difference between the n terms will just start cancelling each other, and I will be left with 1 plus 1 plus 1 n times. When I divide this by n terms, this is nothing but n by n, which is 1. Another way to solve this is simply assume a small value of n, 2, 3, 4, 5, even though they have said n is a positive integer larger than this. You can ignore this and still solve it. You will get the answer of 1. But even if you take this value, you will arrive at your answer. The next question that we look at is question number 78. So this is what I would call more of a trick question rather than anything else. Now 78 appears like a trick question, but this is a pure concept which can be done in 1 minute if you understand the concept. This is based on something known as the binomial theorem, which all of you would have studied in class 11 or even in your theory material that you have. Based on this, if you know the theory that the coefficient of this is nothing but 2 raised to 100, comes directly from the binomial theorem. If you don't solve it, just read the question, see this value, acha 100, 2 raised to 100. But let's say you are not in a position to remember this, or you are unable to remember this. What you can do is first understand the meaning of coefficient. Coefficient is the number next to the variable, which is basically 1x. So what I would do is say what is the sum of coefficients for x plus y raised to 1. Here x is 1, y is 1, and their sum of coefficients is 2. So when this is 1, this is 2. Consider x plus y the whole square. The sum of coefficients would be, because this is nothing but x square plus 2x plus y square, the coefficients here are 1 plus 2 plus 1 equal to 4. So when this is 2, this is 4. Similarly, you can prove that when this is x plus y the whole cube, the sum of coefficients is nothing but 1, 3, 3, 1. That's 8. So when this is 3, this is nothing but 8, which is actually 2 cube. So the sum of coefficients is nothing but 2 raised to n, where n is the power of x plus y. So here the power is 100. So the answer is this. So this is what is known as a concept-based trick question. If you know the concept, you can do it in half a second. If you don't know the concept, you can use such a method, where you take a much smaller value, arrive at, because you know you cannot find this naturally, you cannot solve this. Whenever you cannot solve this, you should look at smaller values and use a pattern. The same logic applies to this question. You have x n plus 1 and you have been given the value of x11, you need to reach x1. Now obviously you aren't going to go from 11 to 10 to 9 and so on up to 1. So there will be some way of going from 1 to 11. The easiest thing to do is either start from 11, find a relation from 11 to 10, then 10 to 9 and reach 1, or start from 1 and proceed. So let's say I consider my n equal to 1. I get nothing but x2 equal to 2x1 upon 2 plus 3x1. You can solve this to get, or you can solve this and get the value of x1 by taking reciprocals and saying 1 by x2 is 2 plus 3x1 upon 2x1, divide kar do and you can get the answer. The other thing to do is take x11 which is given to you. It is nothing but 2x10 upon 2 plus 3x10. This value is given as 1. So you get 2 plus 3x10 equal to 2x10, which means that x of 10 is equal to minus 2. That's one value. Now when you go to x9, you know that this is 2x9 upon 2 plus 3x9. You cancel this off. So minus 2 minus 3x9 equal to x9. And you will observe that you get 4x9 equal to minus 2. Sorry, so you will get x of 9 is equal to minus half. Then you can, if you take one more value, you will be able to start plotting each value and you will arrive at your answer. That is how you can solve each question of this type. The same logic also applies to question 85. I won't solve it, but if you look at it, that's the same logic. That because I have f of a plus b equal to a f f b, I won't be able to find f9. So the best way to solve this is by substituting. How do you substitute? You take 1 as 0 because you want to find 9. Now I don't know any other value, f1, f2, kuch nahi pata hai. So what I do is I take one value as 0, let's say a. So f of 0 plus 9 is equal to 0 plus f of 9. Now here there is a slight concept involved. When you solve this, you get f of 9 equal to f of 9. Let me call f of 9 equal to, let's say, n. Then actually my equation becomes f of n, because this is n, is equal to n. So actually this is my function. Now my question is 1 minute. F of n equal to n, what is f9? Equal to 9. That's my answer. So here the key is realizing that when you write equation this way, this is f of x equal to x. But people get scared by looking at these two f's together. So that is based on a concept plus shortcut. Whereas if I look at question number 84, that's based purely on a shortcut. It looks like a long IFT question. There are 4 tanks having so and so capacity, water is being pumped, whatever. And the process stops as soon as one of the tank gets empty or full and so and so. Now here the key is simply understanding what is the net amount of water coming or going out of a tank. So for A, let's say it would be minus 20 plus 75 minus 10, which is nothing but 45. Similarly, you can find it for B, C and D. Whichever tank, and because everybody is filled at the beginning at 500 liters, observe that 500 is the exact halfway point between 0 and 1000. So if every tank is at this point, it has to either move in this direction or this direction. So you find which of them has the largest efficiency per minute, and that will get full or empty first. That's the trick to be used in this question. Finally, we move to questions 94, which we'll look at very quickly. See here again a concept of functions comes into play. So it is what is known as a knowledge based question, but can be solved orally. The first thing to remember here is that fx is a linear function. Linear function means that fx is of the form ax plus b. That is what is known as a linear function. Had it been a quadratic function, it would have been of the form ax square plus bx plus c. Now, the good part about the linear function is that when you plot it, it will either only keep going up, or it will either keep only going down, or in a third case, it will remain constant. Now, when it keeps going up, my f of 1 will be less than 2, f of 3 will be less than 4, 5 will be less than 6 and so on, because it's this way. So here 1 less than 2 satisfied, 3 less than 4 not satisfied. If it's a function that's going down, then 1 will be greater than 2. So this is not satisfied while this is satisfied. So obviously my function is neither this type nor this type. So obviously it is of this type, and that is satisfied here. Observe that f1 is either less than or equal to 2. f3 is greater than or equal to 4. So all the values are equal. So if f5 is 25, all values of this function will be 25. Hence f7 will also be equal to 25. But this is based on two concepts. What is a linear function and how does it look on a graph? That is how you can solve this question. Finally, if I very quickly look at 96, 96 is a question that can be done either by a concept or by a shortcut. The concept here is that if you know that ax equal to y and ay equal to x, then a of x plus y is 0. That's a standard rule. If these two get interchanged, the sum is 0. But now how do I do it? The easiest way, understand this condition. X and y are both positive integers. So what you do is you take the first as 1. a1 equal to 2. So by logic, a2 will be equal to 1 because they are getting interchanged. And I want to find a of 1 plus 2, which is a3. Now when I look at these two terms, my common difference is equal to minus 1. So my a3 will be nothing but a2 plus d, which is 1 minus 1, which is 0. We got the answer. If you knew the formula, it was a half second problem. So every question or a lot of questions in the exam will either be based on a concept or on such a shortcut, but there will be a lot of logic involved in it. You need to identify that logic rather than remember too many formulae. In general, this mock like CAT had an easy quant section. I would say that you could have easily attempted 24 to 25 questions in that mock. And in general, so when I say 25 questions, it's for quant. Overall, if I consider, we had said that somewhere around 18 attempts for DILR and 15 to 16 attempts for verbal would be good. So on the whole, if I were to be asked, I would say 59 to 60 attempts for the entire mock and 24 to 25 attempts for quant would be a good performance to get a 98 odd percentile in the actual exam, not in our mock, because the number of students taking the mock is obviously way different, and that could have given you a call in most of the good tier 1 colleges. On the whole, easy to moderate mock, slightly easier than CAT, could have been a good start to your preparation. Wish you all the very best. Hope to see you soon taking iCAT23. The analysis for the remaining 2 sections has been posted on our channel. You can subscribe to our channel by hitting the bell button. By doing this, you will receive notifications every time a new video is uploaded. Please give us a feedback on the comment section below this video, or you can even reach us at our support email ID and contact us. Thank you and wish you all the very best.